So why are we talking about supersonics today? It's a really good question. Most of ICCT's work to date has actually focused on the existing commercial jets. We know a lot about those. We're just starting to get our heads around supersonics. The reason being that there are now 3 startup manufacturers that are pushing pretty hard to bring new designs to market, and they're getting a lot of support from the Trump administration. And so there are a lot of possible policy changes coming down the pike, both at the international level and here in the US. And we felt it was really important to get a better understanding of the true environmental performance of these aircraft. So it was our first attempt to model the environmental performance of these aircraft. So we looked at the air pollution, the NOx emitted at landing and takeoff. We looked at the noise footprint, also at landing and takeoff. And then CO2 at cruise, and then what we call mission fuel burn, which is the overall fuel consumed basically moving from airport to airport. So we had a lot of fun with this. We worked with a group at Stanford that has a model, open source emissions model that can handle unconventional aircraft designs. We took as much public information from one of the manufacturers as we could find and fed it into the model. Ended up getting pretty good estimates of NOx emissions, CO2 at cruise, and also mission fuel burn from the model. And then also was able to make a qualitative estimate of the noise at takeoff based upon basically the jet exit velocity coming from the plane. So the findings are really quite interesting. There's been a lot of talk over the years about the gap in fuel efficiency between the original Concorde, which was flying in the 1970s to 2003, and then jets like the 747s at the time. One of the things we found in our work that gap between supersonics and the existing jets hasn't really closed. So we're estimating that a supersonic commercial airliner will be about 5 to 7 times as carbon intensive as a comparable subsonic jet today, which is more or less the same gap we saw between the Concorde and the 747 almost 35 years ago. So we would expect a lot more CO2 emissions from the operation of these aircraft if they are put into service. Separately, we also compared the likely performance of these aircraft to existing environmental standards. So those covered CO2 in cruise, NOx in landing and takeoff, and also noise in landing and takeoff. We were able to do a quantitative analysis for NOx and CO2 and qualitative for noise. And our overall finding is that these new commercial supersonics are likely to fail all existing environmental standards for commercial jets today. The range that they exceeded the standards varied. So about 70% over the standard for CO2, about 40% over the standard for NOx. Noise is a little trickier because it's very difficult to model, but we do expect that these new aircraft will not be able to meet current noise standards and might actually fail the 2006 standards as well.